Okay, so on 13 it's just asking us to evaluate at a certain point. So I'm going to take the derivative, 2x dx dx plus 2y dy dx equals 0. Get dy dx all by itself. That'll happen once I subtract the 2x over and divide by 2y. The 2's cancel, negative x over y. On my second derivative, I'm going to do bottom times the derivative of the top, negative 1 dx dx, minus top times derivative of the bottom, dy dx, all over bottom squared. I'm going to clean this up, plus x, and then dy dx is negative x over y squared. I'm going to clear the fraction with a y over y, and I get negative y squared minus x squared over y cubed, and then it wants me to evaluate that at 8, negative 6. So I'm just going to plug in 8 for x and negative 6 for y. So negative 6 squared is 36 minus 8 squared, 64, over y cubed is negative 6 cubed. 6 and 6 is 36. 36 times 6, I think, is 216, and it'll be a negative. So when you simplify that, 64, 74, 84, 94, negative 100 over negative 216. It's going to make it a positive. Divide both of those by 2, and I'm going to get 50 over 108. Divide both those by 2, and I'm going to get 25 over 54, which is our answer. 15 and 16 are pretty much the same question, phrased a little bit differently. 15 wants to know at what x values the tangent would be vertical, aka when is the derivative undefined. A vertical tangent line would mean that the slope is undefined, which would mean the derivative is undefined. So we're going to take the derivative and see where it's undefined. We're going to do the same thing down here because they ask a little bit more straightforwardly. Find x where the derivative is undefined. So on this one first, nice because we don't have to go into the second derivative. I need more space because I'm seeing a product rule in the middle there. Okay, here. So 2x dx dx minus, okay, product rule. First times derivative of the second. First times derivative of the second minus second times derivative of the first, which is just 1. I'm not going to do negative 1 because I've got the negative out in front. So first times derivative of the second minus second times derivative of the first. Plus 2y dy dx equals 0. And now I'm just going to get dy dx all by itself. So I'm going to distribute my negative. Get rid of my non-dy dx's. Negative 2x minus y. Factor out my dy dx's. And divide that over. So anytime this equals 0, it's undefined. So negative x plus 2y equaling 0 will give us some undefined points. Plus, this still needs to hold true. So we got a bit of a systems of equations situation here. I'm trying to think. How I would solve that. Negative x plus 2y equals 0. I could solve this for x, so subtract 2y over. X equals 2y. If x equals 2y, go up here, take your x's and replace them with 2y. So 2y squared minus 2y times y. So 2y squared would be 4y squared minus 2y times y would be 2y squared plus y squared equaling 9. Solve for y. I get, oh god, 4 minus 2 is 2. 2 plus 1 is 3y squared equals 9. Divide by 3. Y squared equals 3. So y could equal plus or minus root 3. And if y equals plus or minus root 3, then x equals 2 times that. So plus or minus 2 root 3, which is what the answers were for x. And then the last one, same idea, 2y dy dx minus, here's my first, times the derivative of the second, plus the second. Uh-oh. Oops, sorry. I actually did this one wrong back here. I did first times derivative of the second plus, it should be a plus, which means that's a minus. Somehow it didn't affect me though. That's a plus. Oh, because it's in the numerator and that's irrelevant. So if you thought I made a mistake, I did, but it ended up not hurting me. So first times derivative of the second plus second times derivative of the first, which is just 1, minus 3x squared equals 0. Solve for dy dx, distribute first. Get these guys over and factor the dy dx out. Um, 3x squared plus y, and then divide that over. So 2y minus x ends up on the bottom. And so this cannot equal 0, or we kind of want to find out where it does equal 0, because that's where it would be undefined. And again, we're going to do some sort of substitution here. So we're going to say that 2y equals x. So any place we see an x up here, we're going to replace it with a 2y and a 2y. So that's going to produce y squared minus 2y times y is 2y squared. Minus 2y cubed is going to be minus 8y cubed equals 8. We're going to solve for y first and go back and find x after that. So when we solve for y here, we're going to get negative 1y squared minus 8y cubed equals 8. And I think based on the nature of the answers, it's clear that you would need a calculator to get that. So I'm going to go ahead and add these over. So it's going to be 0 equals 8y cubed plus 1y squared equals 8. I'm going to find the solutions for y using a calculator. So I'm going to graph 8. I only have an option to do x to the third plus x squared to plus 8. Get that image, find some y answers, just one answer. Second trace, find your 0. Left bound, left is underneath here, right bound, right is up above, and get negative 1.043. So y equals negative 1.043, and then of course you double that, negative 1.043 times 2, and you get your negative 2.086, negative 2.087. So I shouldn't have rounded that third decimal, because when I doubled it, it made a difference. But that is that. And again, by the nature of the answer options, it was a calculator question. But once you get that y coordinate, you go back and plug it in and double it. Hopefully that's it. Let me know if you have anything else.